All right, welcome. This is video part one of lesson 3.5, and we're going to see how linear inequalities are bounded by linear equations. So let's look at our first example. Younger students at a dance recital perform 4-minute routines, and older students perform 5-minute routines. The total time of recital needs to be 40 minutes. So A asks, what linear relationship will model a combination of younger and older students that will yield a 40-minute recital? And we want to graph that. So we know we have 4-minute routines for the younger students, 4x, plus 5-minute routines for the older students, and that needs to equal a total of 40 minutes. If we graph this relationship, and if we go through and if we find the y-intercept for each of these, the y-intercept is 8. So we go 1, 2, 3, 4, 5, 6, 7, 8. And the x-intercept is actually 10. And so we can actually draw a line between these two to show the relationship. Well, now the question is, how would this change if the recital could be less than 40 minutes, but no more than 40 minutes? It's the same as our equation, only with an inequality sign. So it's still 4x plus 5y. And if it had to be less than 40 minutes or as much as 40 minutes, that would be less than or equal to 40 minutes. What if the recital had to be less than 40 minutes? Well, that just changes the inequality sign. So it would be 4x plus 5y, and it would have to be less than 40. Not less than or equal to, but less than 40. Okay, so let's continue with that idea. Now I want you to try it on your own. Try out this question here. Push pause on the video and then come back. All right, now that you've tried it and you've unpaused this, it says Josephine is selling roses, X, and carnations, Y. Roses cost $3, carnations are $2. She needs to make $24 this hour. Write a linear equation that models how many of each she must sell this hour to meet her goal. Well, that would be 3x for the roses plus 2y for the carnations, and that's going to equal $24. Now we want to translate that into slope-intercept form. So all we have to do is rearrange, and we're going to get y is equal to negative 3/2 x plus 12. So now what that means, obviously we have, it says graph each scenario below and write the linear inequality. So what if she has to earn exactly $24, which is what we've been looking at so far. Exactly would mean equals. So we know that the y-intercept is 12. Let's see, 1, 2, I think this is going up by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12 is going to be somewhere up in here. And then the x-intercept, if we were to map that out, would actually be at 8. 1, 2, 3, 4, 5, 6, 7, 8. And so we can actually, show a line that would go, in both directions. And that's where she would have to be. How about she must earn at least $24? Well, if it's at least $24, we would still have roughly our same line, and then it could be anything on that line or above it, okay? That would be, that it would be greater than or equal to $24. Well, what if she must earn more than $24? Well, now our line actually becomes, we would want to make it dotted because that means we're not going to be on the line, but we do have to be above it. So we can't be on this line, but we can be above the line. and that would be greater than. So this is greater than, can't be on the line, has to be above. Greater than or equal to could be on the line or above, or needs to be exactly, which means right on the line, somewhere on that line to show that relationship.